All right, let's talk about this one right here. It says we have to find the sum of geometric series, and it gives us 3 plus 9 over 2 plus, don't know how many, and then that ugly thing right there. So, man, where even to begin? Sum means we add them all up, right? But it is a geometric series, and IB gives you some formulas. So you can look them up. I'll provide them for you right here anyway. I got them written down. I'll go ahead and write them again anyway. First of all, the way you find the sum is with this formula right here. Now, that could be turned around. It could be r to the n minus 1 and r minus 1. Either way, it's the same. Either way, sometimes it's seen this way. Sometimes you see where they put the r first on the top and bottom, but it works either way. So that's how you're going to find the sum, right? So we need to know r. R is the common ratio. And then U1 is 3. This is the first one, right? So in order to use this, we have to find two things. So let's start off by, we also need to find N. So we need to figure out what is N. We have to figure out what is R. Let's start off with R. The way you find R is you just take two terms and two consecutive terms, and you just divide them to figure out what is the common ratio. So R is going to be UN minus 1. So that means it's going to be like this one divided by the one in front of it. So let's go ahead and do that. 9 over 2 divided by 3, same as times 1/3, right? So this divided by 3 is the same as times 1/3. Reduce. Looks like our common ratio is 3 over 2. So 3 times 3 over 2 is 9 over 2, right? So far, so good. Okay, so now N. The way we're going to find N is we're going to use this formula right here. Okay? Excuse me. So that's our last, right? U to the N is our last, which is this. So we're going to do, and then this one is 3, and we know R. So we know everything except for N. So this means the last value, the last term, UN is 3, and then times R, R is 3 over 2, and then to the power of n minus 1. So this is an exponential equation. We're going to have to use logarithms to solve it. Let's go ahead and simplify it first. Let's divide both sides by 3 to get rid of this 3. 3 goes into that. 2187 times, 2,187 times. So what we have is 2,187 over 128. Like that. That's what we have. So we're going to use a logarithm to solve that. Take the log of both sides, right? Now, if you remember, the reason we can solve this is because we take the log of both sides. One of the properties is exponents become multiplication. So we have log of this equals n minus 1 times the log of that. And so, man, kind of running out of space here. Let's see here. Let's see, there we go. We can still see that. So we're going to divide, right? So we can plug all that in to our calculator, and what you're going to end up with is 8. So you can take my word for it. You can just plug all that in, and it's going to say 8. All right, so let's back up now. Let's see what we've got. We have to find the sum of this entire geometric series. Geometric series, remember, is when you multiply each term by some common ratio to get the next. So what we found is that the common ratio was 3 over 2, divided this one by that one, got 3 over 2, and then we used the formula for a geometric series, to figure out how many terms there were, because we need to know r, which we found, and we need to know n. Okay, so now we know there are 8 terms, right? So we're going to plug everything into that right there. So we've got s of 8, because there are 8 terms we found. S of 8 equals, so u sub 1, in our formula right here, u sub 1 is 3, right? So I'm going to put a 3 right there, 3. And then 1 minus r to the power of n. R is 3 over 2. Power of n is 8. Right, so that's our numerator, and our denominator is 1 minus r, so 1 minus 3 over 2. You can plug that all into your calculator, correct it to 3 significant figures, 148.